Less than 1% of all animals that have ever lived left any trace behind. That means for every creature that walked, swam, burrowed, or breathed on this planet across 4 billion years of life, the overwhelming majority simply vanished, as if they never existed at all. So when something does fossilize, it is already a miracle. But some fossils go further than that. Some are so rare, so strange, so genuinely confusing that even after decades of study, the world's best scientists cannot fully explain what they are looking at. These are not just rare. They are once in history. The kind of discoveries that rewrite what we thought we knew. In 2006, researchers from the UK Royal Society were working in China when they found something that stopped them cold. It looked wrong. The proportions were off. The skeleton seemed to belong to 2 different animals. They assumed there had been a mistake, that 2 separate specimens had been mixed together somehow, that they were simply missing a second body. What they had found was a single animal, a real, complete, fossilized creature. And it had 2 heads. The Hyphalosaurus, the submerged lizard, an aquatic reptile from the early Cretaceous, about 3 feet long in adulthood, built for deep lake water. Webbed feet, a flattened tail, needle-like teeth for catching small fish. In life, it would have been almost invisible in the dark water of ancient lakes, except for the 2 heads. Polycephaly, more than 1 head on a single body. It had been documented in modern animals before, mostly in reptiles, snakes, and turtles in particular. But never in the fossil record, never in anything this old, and never in any animal across all of paleontology had it been preserved in a fossil at all. This specimen was the only one. Out of thousands of Hyalosaurus fossils recovered over the years, this was the single individual born different, because the body was tiny, even by the standards of its own species. This animal died very early in infancy, possibly before it ever drew a breath. Polycephaly reduces lifespan in almost every animal it affects. This one likely never had a chance. Not all rare fossils are rare because of what the animal was. Some are rare because of what they were doing. In 2013, paleontologists working in the Karoo Basin found an ancient burrow buried in early Triassic rock. Burrows occasionally fossilize. It happens. What does not happen is finding 2 animals inside one, pressed tightly together, neither one showing any sign of struggle. Inside the burrow was a thrinaxodon, a carnivorous cynodont, roughly the size of a fox. These animals had been found in burrows before, so at first no one paid it much attention. The specimen sat unexamined for a long time. Then it was scanned. And inside the scan, tucked alongside the thrinaxodon, was a second animal entirely, an amphibian, a brumistega, belonging to a group that had never been known to burrow at all. Their bodies were pressed against each other, tightly, like 2 animals sharing warmth. The first assumption was predation, one hunting the other, interrupted mid-attack. But that fell apart immediately. Neither animal was the other's typical prey. Neither skeleton showed any mark of a fight. What the brumistega did show were injuries that predated the burrow entirely. Fractured ribs on the right side, 2 bite marks on the roof of its skull, old wounds, already healing. The picture that emerged was something far quieter than a hunt. An injured animal, exhausted, in pain, stumbling through the brutal heat of the early Triassic, the sun at its worst. The ground dry and cracked, no shelter above ground. Then a burrow. Dark, cool, already occupied. The thrinaxodon may have tried to drive it out, may have simply ignored it, or may have already been deep in estivation, the warm season equivalent of hibernation, completely unaware it had a guest at all. Whatever happened, the 2 settled in together, bodies touching, waiting for conditions to improve. They never did. A flash flood came. The burrow filled. The two animals were slammed into a corner. They drowned together, pressed against each other, and they were preserved together exactly as they were found, roughly 250 million years later. The only known fossil showing two different prehistoric species in physical contact. Some fossils are rare because of what they tell us about ourselves. In 2012, archaeologists excavating Denisova Cave in the Altai Mountains of Siberia found a bone fragment, a small piece, one of nearly 2,000 poorly preserved fragments recovered from the site, all of them visually unremarkable. Nobody expected anything from it. The fragment was sent for genetic testing, peptide mass fingerprinting, mitochondrial DNA analysis, standard procedure for a site like this, which had already yielded evidence of an extinct human species called the Denisovans. The bone belonged to a girl. She had been roughly 13 years old when she died. She lived about 90,000 years ago, and she was not fully Denisovan. She was not fully Neanderthal either. She was both. Half and half. Her mother had been a Neanderthal, her father a Denisovan. Two different human species, two people who met somewhere in the ancient world and had a child, and that child's bone survived long enough for us to find it. Denny. That's what they called her. She is the only known first-generation hybrid between any two human species ever found. This is the only one. Her DNA revealed more. Her mother's genome matched Western European Neanderthal populations, thousands of miles from where the cave sits, suggesting Neanderthals had migrated east in waves, encountering Denisovans along the way. Her father carried distant traces of Neanderthal ancestry himself, genetic echoes from an ancestor who had lived roughly 18,000 years before him. Two species, two lineages, one girl, one small fragment of bone surrounded by thousands of others that nobody expected to mean anything. The first direct, physical, fossilized proof that our relatives did not just fight each other, they also fell in love. But not every strange fossil comes from a creature we can classify. Some of them, even after decades of study, remain genuinely unknown. In 1966, an amateur fossil collector working in Illinois found something he could not identify. Several somethings scattered across the Carboniferous Mazon Creek Formation. He studied them, he collected them, he brought them to the Field Museum of Natural History and handed them to the experts. The experts were just as lost. The animal had a cigar-shaped body, triangular fins, long stalked eyes positioned on either side of a narrow proboscis-tipped mouth. It looked less like a real animal and more like something designed by someone who had never seen a real animal. Most specimens were under 35 centimeters, small at least, but deeply, genuinely strange. Researchers from around the world took turns trying to classify it. The only agreement they could reach was that it probably lived in water, that it was probably free swimming, that it was probably a carnivore that preferred murky depths. That was nearly 90 years ago. Today, the best classification available is that the Tully monster, as it came to be known, was a bilaterian, a grouping so broad that 98% of all animals on Earth fall inside it. We have narrowed it down to basically everything. It remains one of the greatest mysteries in paleontology, not because the fossils are rare, but because the animal itself simply does not fit anywhere in the story of life that we know. From the same formation came two others, two fossils so strange that the best descriptions available were letters of the alphabet, the H animal, the Y animal, The H animal, formerly named Etacystis, genuinely resembled the letter H, a strange growth in the center, limbs extending outward in ways that made no obvious sense. It was likely colonial, grew throughout its life, fed on free-floating particles, came in different sizes, different shapes, the central sac sometimes circular, sometimes heart-shaped, possibly a hemichordate, possibly not. The Y animal, Esmacia, looked calmer but proved harder to place. It shared features with sea anemones, but also had bilateral symmetry, a complete gut and a rear end, none of which sea anemones have. Its arms may not be arms. What they did is unknown. What it was is still debated. Two fossils from the same site, neither one fitting anywhere, both sitting in the collections, waiting for someone to figure them out. There is an older strangeness still. Go back to the Ediacaran period, 635 to 538 million years ago, before complex animals had fully established themselves, before most of the body plans we recognize today existed. This is when Namacalathus lived. The first time anyone saw its fossil, they concluded it resembled something from another world. Openings at the top, a structure that looked like a tree, except its trunk was calcified. An animal, clearly. But what kind? The question deepened when they found evidence of what covered its surface. Namalathus was covered in tentacles, rows of them, grasping, and rows of spines alongside them, sharp enough to have shredded anything making contact. Those openings at its top were biological windows, filled in life with organic matter, shaped like circles, hearts, hexagons, heptagons, and other forms with no obvious explanation. It could adjust its size depending on where it lived. It appeared almost anywhere, and it preferred the abyssal plains, the deepest, darkest parts of the ancient ocean. Visually, it resembled a coral, but analysis showed it was far too structurally complex for that, so it remains unclassified. One of the oldest animals with a skeleton ever found, one of the most visually disturbing things to emerge from the fossil record, and still, after all the study that has been applied to it, fundamentally unknown. And then there is Denny's quiet mirror image, a story with no creature from mythology, no double head, no amber prison, just a single bone fragment. A specimen was found in 1910 and then nearly forgotten. It was incomplete, confusing, put aside. Then in 2010, 91 new specimens came out of the rock in much better condition, and the animal they revealed was unlike anything previously described. Nectocaris. 2 tentacles, a flat, kite-shaped body, 2 stalked eyes, no visible mouth except a large funnel that may have been a reversible proboscis capable of turning inside out. It looked in almost every way like a cephalopod, and it was proposed to be the earliest known member of that group, predating any other cephalopod in the record by 30 million years. But that created an immediate problem. Its existence went against everything understood about how cephalopods evolved. It was like finding a modern human in the fossil record before any primate had appeared. So that classification was withdrawn, and Nectocaris sits today in a family of its own, a small disputed family with no known relatives and no confirmed place in the history of life. This is what the fossil record actually is, not just bones in stone, not just evidence of things that existed. It is a collection of moments, accidents of preservation, each one requiring a specific set of conditions that almost never align.